Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to the Reliability Matters podcast. I'm so glad you're with me today. This is episode number 95. As I said in our previous episode, we're getting very close to episode number 100. For our 100th episode, we're going to do something a little bit different, something we've never done before. Our 100th episode will be broadcast live. It will be broadcast live on LinkedIn. You can follow me at the handle right here, and on the Reliability Matters YouTube channel on July 26th at 10 a.m. Pacific time. During that episode, we'll replay clips from several of our prior episodes and hear a few comments from some of our past guests. As we creep ever so close to episode number 100, I want to once again thank both my guests and my audience, the viewers and listeners of this show. Without all of you, I would just be a talking head, and Lord knows we have too many of those these days. Don't worry if you can't make it to the live event. After we complete our live broadcast, the podcasts will be available on the usual podcast channels, Apple Podcasts, Google Podcasts, Amazon Music, Spotify, all the others, and on our Reliability Matters YouTube channel. So you'll have a chance to catch it on demand after the live event broadcasts. As we all know, education is an important element within the electronic assembly industry. On today's episode, we're going to talk about education, not the broad education that a college or university provides, rather an industry-specific education. Universities graduate thousands of electrical engineering students every year. These students leave university with a degree and a broad knowledge of electrical engineering. Even with that knowledge, however, there's no guarantee that a newly graduated and hired engineer will know how to specify an adequate solder paste for a specific application. They may not understand solder paste mesh sizes, squeegee pressures, or the art of thermal profiling. They may not be aware of the numerous acronyms unique to our industry. Frequently, this education comes from on-the-job training. That's when a membership in an industry association and access to its technical resources becomes so valuable, both to the employee and to their employer. SMTA, the Surface Mount Technology Association, provides its members access to numerous technical resources, including more than 5,000 technical papers, scores of both live and on-demand technical webinars, technical conferences and symposiums, and process training courses, as well as certification programs. And that's what we're going to be talking about today. On this episode, we're going to talk about the certification programs that SMTA offers. SMTA offers its members access to two unique certification programs, the SMTA Processes Certification Program and the Lean Six Sigma Green Belt Certification Program. On this episode of the Reliability Matters podcast, we'll talk to two of the creators of the SMTA certification courses, as well as two of its former students. So without any further ado, let's bring on our panel. Well, welcome everybody. Thanks for either being told or volunteering to be guests on this show. I appreciate you being here. How are you all today?
Amazing.
Good, Mike. Thank you for inviting.
Amazing.
Yes. Wonderful.
That's a high bar. Amazing. We're going to have to work to keep up with that. First, let me introduce everyone. I mentioned that we have two of the creators of the SMTA certification course. Let me introduce first Dr. Ron Lasky. As you may recall, if you watched this episode a couple of weeks ago, Ron was a guest on my last episode of the Reliability Matters podcast, where he discussed some of the books that he wrote and one that he didn't write. Dr. Lasky is a senior technologist at Indium Corporation, as well as a professor of engineering at Dartmouth College. Dr. Lasky has more than 30 years of experience in electronics. It's hard to imagine since he's only 28 years old. And he has 30 years of experience in electronics at IBM and Universal Instruments and Cookson Electronics, and of course his current gig at Indium. Next, I'd like to welcome Jim Hall. Jim is the principal engineer, principal SMT consultant, and resident Lean Six Sigma Master Black Belt. I love that title. I just love the title Black Belt in anything, even if it's not on a rubber mat. It's pretty cool. And he's with ITM Consulting. Jim is one of the pioneers of reflow technology and has been actively involved in the electronic assembly technology for more than 26 years, creeping up on Dr. Lasky. Jim's expertise lies in process development and integration, fluid and thermodynamics, and computer-controlled systems. Jim is also the co-host of CircuitNet's Board Talk. Speaking of Board Talk, Jim is the co-author, along with his partner in crime, Phil Zarrow, of the newly published book, Troubleshooting Electronic Assemblies, Wisdom from the Board Talk Crypt, which is available on Amazon. And Dr. Lasky and I talked about that book on the last episode, if you recall. I'd also like to welcome two SMTA Certification Course graduates, Claire Hotvedt and Tom Watson. Claire works at Indium Corporation. Tom works for Kimball Electronics. That's a very long introduction, but welcome, everybody. Thanks again for being my guests on Reliability Matters. Appreciate you being here.
Thank you.
Thank you.
Let's begin with the inception of the certification courses. Where did the idea come from? What was its inspiration? I'll let Dr. Lasky or Jim Hall tackle that question.
Why don't I start, and then maybe Jim can chime in. So it's about, I'd say, in the early 2001 timeframe where it occurred to Jim and I and Phil Zarrow that in the many factories we visited in the world, which together, I'm sure for the three of us is well over 100, that many of the process engineers often didn't know some of the basic things. And I think some of them you mentioned, Mike, like how to set up a reflow profile for a solder paste and how to time balance the chip shooter with a flexible placer, or how to design a stencil. So we talked to Joanne Stromberg about when maybe it would be helpful if there was a program that was a day and a half of teaching the material, which we assume the students come to the class with some of the material, and then have a pretty long closed book test for a couple hours, and then an open book test for a bit longer than that. And in 2002, we kicked it off at SMTAI, so it's 20 years ago. So maybe Jim can add a few points that I may have missed.
Jim?
Yes, I like to emphasize what Ron said, that it's not an entry-level course. It's not a beginner's course. We expect some people come in knowing virtually all the material, depending upon their level of experience. But the most important thing is we cover the entire assembly processes, all of the process, or most of the major process steps, and it allows people to fill in gaps where they haven't had specific training and get a basic level of understanding of the whole process.
Excellent. Let's walk through the SMTA Process Certification Course, starting with who's the intended student? What types of people, at what point in their career, what careers would they be in to get value out of this course?
Maybe I'll take a stab at that, and Jim can add in. So we assume that the typical student would have at least a 2-year degree in some technical curriculum and have worked probably for something like at least 6 months and maybe a little longer than that, and has the basic type of skills you would think an engineer would have, like was pretty comfortable with basic mathematics like algebra and geometry, no calculus, and has been around SMT assembly long enough that they know basic things. And as Jim said, some people come to the class, literally it's just sort of brushing up a little bit. And then there are others that really, there are quite a bit they can learn in the workshop. So I think if you've got a technical background and you've been in SMT for a while and you're capable of learning material, as Jim said, pretty much all that's on the exam is covered in the workshop, but it's very, very fast. It's a lot of material. And I guess one other thing, the people that struggle typically are the ones that have trouble with the mathematics, and it's algebra and geometry. It's not beyond that, but some people struggle with that quite a bit.
Not a lot of calculus in this
No,
course.
no calculus.
Excellent.
No calculus.
All right. Well, I might stand a chance. You mentioned the prerequisite. You like to see at least a 2-year, like associate's degree. Do you ever have anyone come to the course with maybe some on-the-job experience enough to pass the course without a college degree, without a formal college degree?
Yes, very much so. We have people who have don't have much formal education, but have been in electronic assembly for some period of time, 10 years or more in some cases, and have learned through in-house training and their own efforts. But this is more typical to people. The problem, as I alluded to before, is that they have gaps in their knowledge. Some things they just haven't had to work with in their specific work environment. So we give them this course gives them a chance to see how that part of the process and get the fundamentals.
Right. There's a such thing as you well know, Ron, in your position as a professor. There is this mental atrophy that takes effect. If you're not using something every day, it tends to slowly drift off into the sunset. Is there such thing as, and do you recommend preparing to take this course? And if there is a recommendation to prepare to take the course, what would that preparation involve?
Well, it's interesting because I'm giving a workshop with Indium Corporation on just that topic. I would say the most important thing for people, at least the thing people struggle with, is probably a review of algebra, solving simple algebraic equations, and not being something like 2x plus 7 equals 4x minus 3, to be able to solve that and not feel somewhat intimidated. That would really be helpful. And of course, some people, especially brand new college graduates that have like a bachelor's degree in mechanical engineering, to them the math is really straightforward. But at least in my experience, most of the people that do struggle with the math.
Right. Are most of the students electrical engineers or mechanical engineers, or just a combination of all sorts of things?
I would say a combination of a lot of different skill levels, probably more towards the mechanical and industrial engineering than the electrical engineering. Typical electrical engineers are people who would be designing the products, much more so, whereas mechanical engineers, industrial engineers actually assemble products.
I'll put you guys on the edge here without preparation for this question. If we look at all the knowledge required to work on an SMT line effectively, and say all the knowledge is 100%, you have 100% of that knowledge. When someone graduates college or university, what percentage of all the required knowledge would you think that the average graduate would have? In other words, what I'm trying to get at is, how much are you backfilling? How much are you adding to their education with this with these courses? Does that make sense?
Yeah,
question.
I think I have an opinion on that. If you take a brand new college graduate that's worked maybe 6 months on the assembly line and is curious, he or she will probably do quite well. There will be things that they will learn. But I would say it's not so much the knowledge that is a problem for people that struggle. It's their skill level. Can they pick up things quickly, especially things that relate to, as I mentioned, the algebra and a little bit of not calculus, but geometry. But one of the things that I think surprises instructors like Jim and I the most is that some people who have worked for quite a few years will come to the course and not know something like, the pretty common solder we use is SAC 305, SAC 305. And often when I teach, I give a little pre-test and I ask, just to see where the students are asked, and that's one of the questions I usually ask is like, what does the S stand for in SAC 305, and how much silver is there? And I'm going to say less than half of people that come to any of the workshops or even a certification course that I teach know some of these things that you would think that they would know from working. And so I say the person that's going to do the best is a person that's pretty comfortable with algebra and has been curious, even if they've only worked for 6 months. when they pick up that jar of solder paste, they say, hey, this says SAX 305. I wonder what that means. I'll go ask Charlie. I've only been here a week, but I want to know what that means. And to know what like a type 4 solder paste is, what that means about the powder. And you mentioned that as your intro. That's kind of my experience.
Yeah, I love working with curious people. I've always been a curious person. I mentioned this on the show before, and I may have mentioned it to you, Ron, on a prior conversation. When I was a kid, I used to get in a lot of trouble because I was curious how things worked. So I would take apart all of my parents' appliances, clock radios, televisions, record players. That didn't get me in trouble. What got me in trouble was I didn't have a great desire to put things back, or not completely. I'd always end up with the 3 or 4 extra screws and whatever.
Screws, yeah.
But yeah, I think was it Steve Jobs at a commencement address, maybe at Stanford, or someone said this. Stay curious. And I like working with people who want to understand, even if it's not important specifically to what their job is. I like people who dig in deeper and get the meaning behind the meaning. How long are these courses?
Why don't I let Jim comment, since I've talked quite a bit.
The process certification course is 3 days long. As Ron described, it's about a day and a half, a day and 2/3 of review and teaching. Then the last 2 hours of the second day are an open book, a closed book exam. And then the entire third day is simply a review of everything we've covered, answering any questions. And then the students have like 6 or 7 hours to complete the open book exam.
So there's closed book and open book. That, of course, guarantees that someone has to have some level of retention, or the ability to find the information when they need it. In terms of the open book, is there a percentage? Do you calculate and track the percentage of people who pass the course and fail the course?
We have a pass between 85 and 90%.
Okay. Yeah, I've taken some over the years. I've taken some what I'll call lightweight courses, and just to fill in some knowledge, not with SMTA, by the way. And those courses I was all but guaranteed to pass because, when you take the quiz, particularly an online course, it'll ask you A, B, C, or D, and if you choose C, it'll say no, try again. Within 4 tries, you're going to get the right answer. Everyone passes. Everyone gets a medal, that type of thing. Which
I think Ron should talk about the philosophy of the open book test because he created it.
Yeah, let's go there.
Yeah, this is very important, not only for the SMTA certification that we're talking about today, but for the green belt. And then I have a complete Lean Six Sigma program at Dartmouth where we give yellow belts, green belts, black belts, and even master black belts, which is what Jim got. And I discussed it in the very beginning that all of our exams would be problem-solving exams, not multiple choice. And so you have to solve problems. And I just feel passionate about that because of the whole multiple choice concept. One of the reasons I think a lot of places do that, even organizations like American Society for Quality, I believe, has a multiple choice test to get a black belt. I just, when the assembly line is down, God does not have a tablet come from on high and say, what's the problem? Is it A, B, C, or D? You've got to really be able to solve problems. And so that is one of the reasons the open book test takes 6 to 7 hours, because it is a problem-solving test. The closed book test, we just feel it's got some simple calculations, but we Jim and I and Phil talked about this a lot. We just didn't feel comfortable letting people have the title of a certified process engineer if they didn't just have some internal knowledge. After the course, like what is the approximate melting temperature of SAX solder, those kind of things. We just felt it isn't right for someone to be certified if they don't carry with them a certain amount of knowledge in their head.
Yeah, that's true. In this day and age, you date yourself when you use phrases like this day and age. But certainly in modern times, it's not how much we know, it's how quickly we can get the answer. And there are a host of resources these days to get those answers. And knowing where to turn is certainly valuable in its own right. whether you have the answer instantly or in a minute or two. It really, that part doesn't really matter as long as you have access and you know how to get the answer and you know what questions to ask. Walk me through, I know there's a couple of courses. Let's start with the SMTA Process Certification Course. Walk me through what that curriculum looks like.
All right, I start very fundamentally. This is the electronics industry. We build working electronic assemblies. And then we talk about what a great industry it is. And then we do a general overview of electronic components, the different styles, and we do a general review of soldering. Then we go into the specific process steps in the sequence that they typically occur in an assembly line, starting with solder paste, printing, and stencils. And then we go into placement, then the different soldering operations, reflow, wave, and selective. We do dispensing and coding. We do a test, and then we do a line optimization. So that's pretty much the curriculum. Did I forget anything, Ron?
No, that sounds good.
Excellent. I lost my place here. Excellent. Where does one take this course? Is this something that someone goes to a venue to take? I know it's offered at SMTAI. Is that the only choice? Can they take it online? I would assume after a couple of years of COVID, that may have been an option. Can it be taken at their facility? Anyone? All of the above?
We do not do it currently. Yeah. We're investigating that, but the difficulty with the exam has precluded us feeling comfortable doing that. All of the above. Sometimes a company will have a dedicated session which they can contract with the SMTA for, where Ron or myself or somebody will go into their facility and give the course to exclusively their personnel. Some companies will host it and open it to other people from the industry in their area, but they have it in their facility. We do it at other trade shows. Some of the SMTA chapters have sponsored it for their membership and so forth. But typically it's somewhere where you would go someplace to some venue to take the course.
Outside of COVID, because everything's weird during COVID, but out in quote unquote normal times, what would the average class size be?
About 10, I would say.
That's good. So there's a great ratio between instructor and student.
Yes, it's a chance to really get to know the students and hopefully to have a good communication with them. Even with students sharing some of the specific knowledge that they have in particular areas, which is a very exciting part of the class. I learn things from the students who are out there working on the cutting edge of certain process steps that I just haven't had that experience. We try to allow time for a certain amount of that, although we're focused on the fundamentals.
Teacher teaches the student, student teaches the teacher.
Yeah, right.
Very good. The original course debuted, several years ago, right? When I think 2001 is when the idea was born. Did I understand that correctly?
Yes.
Okay.
Yeah.
So not much has changed in the electronics industry since 2001, tongue in cheek.
Well, we had, we of course had the big change from lead-free or leaded to lead-free. And we make an effort, it's mostly been done by Jim, to keep up with, things like, I don't believe in 2001 bottom terminated components. If they even existed, they were very common, and now they're like 15% of assembled parts. So we take the program, and as I said, Jim mostly does it, keeps it up to date. So
I can only imagine, all of a sudden.
We have a committee within the SMTA.
Yeah, it's true too.
Certification committee, and I, as I said, I honcho the curriculum most of the time, but we have people from various disciplines on the committee, and they review any proposed changes, and they will propose changes, and we debate about bringing new material in and letting older material, dropped from the curriculum. So it's a continuous process. I think we're on revision 21 of the curriculum.
Wow. So it's quite a dynamic course.
Early on, some of those were major. We decided the initial course had no information on surface finishes on PCB boards. And we said, wow, that's important. So we created a section, and that was a big revision.
Right. I can only imagine if I were a fly on the wall, when QFNs were dropped from component heaven onto us, there must have been a few phone calls made and some scrambling, like, oh my God, what do we do with this? BGA, same thing, although BGAs were probably around before the course was conceived. But yeah, you guys went right through lead-free. You're going through solder finishes. You're going through an historic volume of miniaturization and bottom terminated components. IoT and automotive are probably game changers as well, because some of those have unique requirements for reliable products, to produce reliable products. So I think in terms of course development, you and your committee really will not run out of things to do in the near future.
Right. Yes.
So yeah, that's true. But I really want to emphasize the fundamentals haven't changed. The base information about soldering and placement and accuracies and so forth. The fundamentals aren't changed. We're just pushing them to greater and greater limits, basically smaller and smaller.
Right. Yeah, for sure. And that affects everyone in our industry.
Basics, and then bring in the newer things as they become predominant in the industry. We don't feel a need to introduce a new technology when it is in fact a new technology. We like to say the students have the background to deal with these new technologies, because the new technologies keep coming. And you certify today, and you may not. You have to deal with something that, like BTCs, that weren't available or weren't even invented at a point. But if you have the basics, the understanding of the interrelationships and the process steps, then you are better prepared to deal with the inevitable new technologies that are part of our industry.
Sure, the basics are the same. The procedures might vary, but the basics are still the same. The evolution of the electronics industry seems to move as fast as electrons, right? It's a speed of light kind of industry. And while many things you teach are constant, i.e. the fundamentals, as you mentioned, many other challenges are added or changed, modified on a regular basis. Is there such thing as a refresher course? Keeping in mind mental atrophies we talked about earlier. If someone wants to be recertified, I don't know if the certification expires, but if it does, is there a recertification process, which is maybe a lighter course, or do they just take the whole course again?
Why don't you comment on that, Jim?
Yeah, we have a recertification course that is online, and it does some of the things. It initially started covering all the new things that have been changed in the curriculum since the early days, and so it's a rolling curriculum. As new things are added to the curriculum, they become part of the refresher for people who took the course 5 or 10 or 15 years ago.
Let's switch gears a little bit and talk about the Lean Six Sigma Green Belt certification. Tell me what that course is all about.
That is pretty much what it sounds like if people are familiar with Lean Six Sigma. It's teaching essentially optimizing processes, and it has two aspects to it. One is the mathematics to analyze the data that is collected, but it uses a basic what's called DMAIC approach: define, measure, analyze, improve, and control. So we teach the students how to take processes in general, measure where they are, develop an improvement plan, execute the improvement plan, and then make sure you can control what you've improved. We focus on electronics assembly, but the Lean Six Sigma in general applies to broadly processes, not necessarily just SMT processes. So it started at our program here at Dartmouth, we developed a program, and we also work with SMTA to have the program. It isn't anywhere near as well subscribed to as the Certification of Engineers program. So it's usually run maybe once a year at SMTAI.
If I were a business owner, say for a contract assembler, or maybe even an OEM, I would want to send the majority of my operators to a Lean Six Sigma class. Two things that are important. One is the fundamentals. Know how to reliably solder a circuit board, to put things simply. And the other is to know how to do it efficiently, right? So, one will get the job done. One will make you money or more money, and allow you to be more competitive. I interviewed, I think sometime last year, the production manager from Matrix Group, which is a mid-sized contract manufacturer in the Northeast, and Patrick Stimpert was his name, and he was a big lean person, right? He's very into lean. He invented his own version of lean. He called it lean in manufacturing. He even built a figure 8 production line rather than a linear production line, so that people wouldn't have to walk from one part of the building to another, to get parts or et cetera. He took lean to an extreme, but he mentioned that it's his belief that any North American contract manufacturer in this case could be competitive with any contract manufacturer anywhere in the world, particularly Asia, if they lean themselves out, because equipment costs the same no matter where in the world you are. The cost of people varies, but with a very lean process, a very efficient process, a super optimized process, you don't need as many people. So it all kind of comes out in the wash. And his contention is that North American manufacturers can be exactly as competitive, if not more, through lean processes. So I see that as a huge value, and I see the lean, the Lean Six Sigma Green Belt program may be more attractive to managers and corporate types because there's definitely an ROI on that, right?
Mike, I want to stop and go back to process. In the process certification, we covered what we consider to be two of the major sources of inefficiency in specifically the SMT assembly process, and that is line balancing the placement machines and dealing quantitatively with downtime. Everybody knows that these are downtime, or the positive side, utilization of your capacity is really important. It's one of the things I believe that can make us competitive, as you're talking about. If we could just be more productive, keep our lines running and running more efficiently, and we address two of those specifically in the process course. And then again, is balancing multiple placement machines, them typically being the gate of your line or the slowest machine. So optimizing those and quantitatively measuring and doing some simple calculations with downtime. All these little sources of downtime that add up to 50, 60, 70% loss of capacity, loss of utilization in our lines. And this is some of the math that Ron was talking about that we do. And it's not complex. It's simple algebra in most cases, a little bit of geometry. And we feel it gives us students a really good picture of these inefficiencies and how to put some simple numbers on them and do some simple calculations to understand the impact they're having on your overall productivity and your bottom line.
In the 15 minutes or so we have left, before we turn our topic over to our graduate students here who've been waiting patiently, let me ask you, are you aware of how people get to take the course? Is it the desire of the student? Does the student go to management and say, hey, I want to take this course? Or does management direct the students to take this course? Or do you have any feel for that?
It's both of those.
Yeah, I agree.
People who want to do it, they want to have the credential personally, so they can have a better bargaining chip with the company they're at, or they can have something on their resume if they want to change jobs. And then there are people like your friend who appreciate the value of this and are sending their a number or some number of their people to the course and sponsor it, and some of them to the point of sponsoring it in-house.
Well, it's a perfect question, actually, for our two students of this course, Claire and Tom. What drove you to the courses? Was it your idea? Was it suggested that you go?
I can start. It was suggested. I think, depending on the department overall, we've definitely encouraged our people in various departments to take this course, ranging from those who actually provide technical support to customers and work on the lines regularly, in addition to those who may be in far greater specializations, and therefore might not know the background or the history and the context of SMT overall. And so even on both those spectrums, those of us who might be a little bit more customer facing will often say, oh yes, make sure to put me on the list for the next time there's enough interest in the SMTA course, because it does add to our credentials and it does improve our overall knowledge when interacting with some less familiar areas. And then in the cases where we have specialists that might not be familiar with the breadth of SMTA, it's also something very much the company encourages to make sure they have the background to then carry with them to those specialized areas of work.
And what course did you take, Claire?
I took the SMTA Engineering Certification Course.
Right. And what is your role at Indium?
So I'm a product development specialist. I focus on solder paste. So it was rather a good fit. I definitely had some useful things to learn in regards to the wave soldering process and line balancing, although we do provide some technical support to customers, not generally on line balancing. So both of those were valuable things to include for me personally.
Excellent. And Tom, what course did you take?
I took the SMT Process Certification, and actually it was driven by myself. I actually sought out to take the course, and it was actually given back in 2012 at Kimball Electronics, and it was all the engineers who went to the course. So when it was coming around this time, about a year out, I said, I want to be included in this course here. And I work within the quality group. So, when I knew as the course was coming up, I actually sought out and obtained an older revision of the SMTA certification booklet. And I spent about a year just reviewing it. After working on the floor, running experiments, I really wanted to review the material right there and prepare ahead of time. So, when the course came up right there, I already prepared ahead of time, but also during the course, I went home at night and actually studied the materials there. And I just gained a lot of knowledge. I thought it was great. You get a lot from experience, but also the fundamentals. What's the fundamentals? Line balancing was a key one right there too. The exercise we had is, you're designing an assembly. What type of circuit board finish you're going to use based on the conditions you're going to be selling it at too. So great experience. I mean, like I said, I really highly recommend it to all quality process engineers, and even, like I said, supplier quality. I highly recommend the course there.
How much of what you took away from the course was old knowledge, long forgotten, and how much was new knowledge? Was there a balance there? Was there like in percentage terms?
I think there was balance. About maybe about 40, maybe about 30 to 40%, maybe lost over time right there. So I think about that percentage there. And
Claire and Tom, how, after taking this course, how has that landed in your career? Obviously you took it, Claire, you took it while you were at Indium, and you're still at the same company, Tom. But how has it affected your day-to-day responsibilities? Has it rocked your world? Has it provided subtle improvements in terms of process knowledge and your comfort level with perhaps things you weren't as comfortable with? Give me some examples of how the course has benefited your career and your day-to-day activities within your job.
So I took the course more recently,
Franklin,
so if you want to take that on.
Go ahead, Claire, and then we'll get to Tom.
Okay, I was about to say I took the course far more recently, so it hasn't necessarily had the time to have the same level of effect. But I do find the additional comfort with the history. For example, you might know the different component types and know our internal recommendations and trends, but understanding the whys and how we got to our current set of options and our current set of materials and components has definitely been an improvement, understanding the narrative of SMT progress.
Excellent. And Tom, I think I may have cut you off. Or was that Jim? Someone was going to say something.
That's fine. Sure. Well, right after the course, probably about 6 months, I got pulled into a problem that a group was actually trying to work on, and it was excess voiding in one of our high volume automotive assemblies. And I got pulled into it, and they were kind of, working around it. And I started, said, okay, what's using, of course, the measurements, how much voiding we have, what's the upper spec. But then we got into the analysis where we had a fishbone diagram. And from the course, one of the things I asked well, based on the solder paste, do we have room for more soak time in the oven? Because looking at what caused voiding, insufficient soak time in the oven. And one of the engineers on the team says, yes, we do. We can extend it by about 9 seconds. One of the other things, too, was cause avoiding excess solder paste. So I said, is there other stencil designs we can use to reduce the aperture size in different shapes throughout? We did an experiment there. And by doing both scenarios, increasing the soak time in the oven, redesign the stencil to reduce the aperture size there, actually went from avoiding averaging of 20% down to 12% there. So it made a really big impact. I mean, from a savings perspective, because if we had one void on the shop order, the entire shop board had to go through X-rays. You can imagine how that backed up your capacity right there too. So I really put it to use right there. Really, really good.
Excellent. And Ron and Jim, I'm sure you've heard stories like that from your students after they graduate.
Yep.
Sure.
Yeah, excellent. Let's go back to Ron and Jim as we conclude. Are there any more certification? I mean, besides the constantly evolving certification courses, the 2 courses that are offered now, is there any talk of any additional courses in the works?
Well, I think Jim mentioned there is the follow-up after you've been certified for a while, but I don't know of anything beyond that. Do you, Jim?
Some people would like to see a more advanced course covering the latest and greatest on BTCs and so forth from a process standpoint.
Well, there you go.
But we have not acted upon that yet.
Yep.
Well, there's always the future.
Yep.
Before I say thank you to everyone, I want to let our audience know how they can get more information on this course. If you simply go to smta.org, hover over the technical or the knowledge base and choose certification courses, you'll see an entire page dedicated to it. It'll answer a lot of the questions you might have, including who should take it and what the prerequisites are. It'll give some testimonials of students who have taken the course, and it'll even tell you how much the course costs. Of course, it's less money if you're a member, another reason to join SMTA. But it's not limited to just SMTA members. It's available for everybody. Dr. Ron, Jim, Claire, Tom, thank you so much for being my guest today. Anything to add before we get out of here?
I think you did it.
I think you guys did it. Excellent.
It's been very
Well, Ron and Jim, and I think Phil Zarrow was part of the group as well.
Yes.
And the committee, the folks behind the curtain that are making important decisions about what's in this course and what isn't in this course, and what needs to be in the course in the future. Thank you all for the work you do. I think it's an extremely valuable asset to an SMTA member to be able to access courses like this. And again, as the owner of a manufacturing company, I'm pro-education. I think it's an excellent investment that any company can make in their employees, not just for the benefit of the employee, but I think that benefit rolls uphill and benefits the company itself. And that can be seen on the bottom line, either in building more reliable assemblies or building more reliable assemblies more efficiently. So kudos to all of you. And Claire and Tom, thanks for agreeing to share your experience with this course. Claire, you probably have a little bit of time before you need to take a refresher. Tom, it might be time for a refresher, so sign up. And I'm sure that you get some extra credit for being on this show, talking about the certification process. So thank you, everyone, again, for being my guest today. And I'll look forward to seeing you now that the world's opening back up again. I hope to see you all at the next conference or convention or wherever it takes us.
Thank you for having us.
Thank you very much. Thank you.
Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeConrad.com, that's Conrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.